Welcome to the Explainer. Today, we're diving into one of the most fascinating and honestly hotly debated clashes in modern engineering. We are putting two radically different pieces of hardware into the ring, the Arduino and the PLC. If you've ever walked onto a factory floor or tinkered at a workbench, you know exactly what these are. But figuring out where one belongs and the other absolutely doesn't, that's what we're going to solve today. Get ready for the ultimate industrial automation showdown. Here is the tale of the tape before our prize fight begins. We'll start with the automation showdown, introduce our scrappy challenger, the Arduino, and then meet the heavyweight champion, the PLC. After that, we'll grade them on a head-to-head scorecard, figure out how to choose the right tool for the job, and finally, reveal the ultimate solution. Okay, let's dive into this. Section 1, the automation showdown, the ultimate factory debate. Every single day in engineering departments, literally all over the world, managers who are looking to cut costs are asking, hey, can this highly affordable microcontroller actually replace our incredibly expensive industrial equipment? Meanwhile, the veteran engineers are pounding the table demanding absolute reliability. So we're looking at two fundamentally different identities here. On the left, you've got the Arduino. It's built to be flexible, super fast, and an absolute dream for prototyping. And then on the right, the PLC. It's unapologetically reliable, heavily certified, and built strictly for heavy-duty production. To really wrap our heads around why this debate gets so heated, you just have to look at the sheer financial stakes. I mean, you can pick up a basic Arduino Uno for, about $10? On the flip side, outfitting a top-tier PLC system can easily scale way past $5,000. With a price gap that extreme, it's completely natural to ask, can the $10 board really do the job of the $5,000 system? Let's find out. Moving to Section 2, Arduino, the scrappy challenger. Stepping into the industrial boxing ring first is the Arduino. This is the affordable underdog that has, quite frankly, revolutionized how we prototype. And its weapons? Oh, they are formidable. First off, the cost is practically zero. You're looking at $10 for an Uno, maybe $20 for a Mega. Its speed in development is just unmatched. You can literally connect a sensor and have it running in 10 minutes flat. Plus, it's got this rich ecosystem of ready-to-use libraries for Modbus, I2C, SPI, and UART. Add in a massive community of millions of users sharing example codes, and you get ultimate flexibility. It's compatible with almost any module out there. So the crucial point is, if this thing is so incredibly powerful and practically free, why isn't it running every single factory on Earth? Well, take a look at these limitations. The Arduino has zero industrial certification. It is not CE, UL, or IEC compliant. Its physical durability is really low. Put it in a real factory environment and it is highly vulnerable to dust, heavy vibrations, and EMI, that's electromagnetic interference. Worse yet, there's no real-time processing guarantee. Trusting it with critical control loops where a microsecond delay means disaster is just a massive risk. On top of that, its future is uncertain. There's no solid guarantee that exact board will be manufactured 5 years from now. And of course, absolutely no enterprise-level tech support to call when everything suddenly goes sideways. Which brings us to Section 3, the PLC, our heavyweight champion. In the other corner of the ring sits the undisputed gold standard of industrial automation. But to understand the PLC, you really have to understand the rulebook it plays by. Have you ever heard of the IEC 61131 standard? It isn't just a friendly suggestion. It's a strict, mathematically rigid international baseline. It dictates the intense safety, reliability, and programming requirements these controllers absolutely must meet. So when a factory manager sees this standard, they know for a fact they have a device legally trusted to run their operations without catastrophic failure. The champion's strengths heavily reflect that rigorous standard. First up, PLCs are fully certified. They are completely ready for all your CE, UL, and IEC factory documentation needs. We are also talking extreme durability here. These machines are literally built to survive anywhere from -25 degrees to +70 degrees Celsius. They just shrug off dust and moisture like it's nothing. They also offer guaranteed real-time processing, meaning you get perfectly predictable scan times for critical control. Plus, they're backed by industry giants. Think Siemens and Rockwell, who guarantee 20+ years of support. And to top it all off, they have native, built-in communication protocols like Profibus, Profinet, Modbus TCP, and Ethernet IP right out of the box. But even a heavyweight champion has weaknesses. For PLCs, the biggest one is the absolutely massive expense. Just an entry-level model is going to set you back $300 to $500, and complex systems, they quickly scale into the thousands. They also have a famously steep learning curve. You can't just plug and play. You need specialized, highly complex software like TIA Portal or Studio 5000. And their architecture is super rigid. Just wanting to add one new type of sensor might force you to buy a totally separate, incredibly costly module. Because of all these factors, doing trial and error prototyping with a PLC is frustratingly slow, and financially, it's just punishing. All right, Section 4, the head-to-head scorecard. Let's see who actually wins this match. And this brilliantly illustrates our comparison across 6 key criteria derived directly from our source analysis. Let's tally up the points. On cost, at $10 to $20, Arduino easily takes the win. For programming ease using C and C++, Arduino wins again. But then, the tables completely turn. When we look at durability in harsh industrial environments, the PLC dominates. For strict legal certification, PLC wins. For a guaranteed 20-plus years of long-term support, the PLC takes it. But for blazing fast prototyping, that final point goes right back to the Arduino. So, tally it all up and look at that. We have a final score of Arduino 3, PLC 3. It is a dead tie. But hey, here is the real plot twist of this whole explainer. This isn't a boxing match where one has to completely destroy the other. Actually, scratch that. It's way more like a buddy cop movie. These two devices aren't enemies at all. They are entirely complementary tools that actually complete each other. Let's move into Section 5, choosing the right tool. Which one, in which situation? Understanding that these tools are complementary honestly changes everything. The real skill for an engineer isn't about blindly defending a favorite brand. It's about knowing exactly when to deploy each specific piece of hardware. So I want you to ask yourself right now, looking at your own projects, which one in which situation? How do you actually bridge the gap between classroom theory and a real-world factory floor deployment? Let's run through 4 very specific scenarios. Scenario 1 is R&D and prototyping. Imagine you're developing a brand new system from scratch, and you know there are going to be a ton of frequent design changes. The clear winner here is the Arduino. Why? Because it's unbelievably fast, it's cheap, and it's completely flexible. It acts as the absolute perfect sandbox to quickly validate your ideas and prove that your concept actually works before you go and burn massive amounts of your budget on industrial hardware. Okay, scenario 2, critical production lines. Let me ask you this. Would you honestly trust a $10, totally uncertified circuit board to run a multi-ton industrial press machine or high-speed packaging conveyor belt? Absolutely not. No way. The undisputed winner here is the PLC. These machines literally demand 24/7 reliability, extreme physical durability, and rigorous certification. The PLC is specifically engineered to ensure maximum uptime without risking any kind of catastrophic failure. Moving on to scenario 3, small IoT and monitoring. Let's say you just need to collect some simple, non-critical data. Maybe you're logging the ambient temperature in a warehouse, or just monitoring the basic on-off status of a remote pump station. The winner here? The Arduino. Look, human safety and critical line uptime aren't on the line here, right? So you can just pair it with an ESP32 or a basic Ethernet shield, and you've got yourself a brilliant, fully networked data logger for a fraction of the cost of a PLC. And finally, scenario 4, functional safety. Now, this is where things get deadly serious. We are talking about emergency stop buttons, light curtains, and critical machine halts. The winner here is strictly a safety PLC. Listen, building a safety-critical system with an Arduino is a massive, totally unacceptable risk. You strictly require the mathematical, guaranteed certainties provided by IEC 62061 or ISO 13849 standards, and literally only a certified safety PLC can deliver that level of trust. Which brings us to Section 6, the ultimate solution, better together. Let's move to and see how this builds our ultimate strategy. We've broken down their strengths, we've mapped out their weaknesses, and matched them to their real-world scenarios. Now look at how these two powerhouses integrate. You really don't have to choose just one. The most powerful engineering solution is actually a pipeline. You start over on the left, prototype with the Arduino. That gives you the speed, the minimal costs, and the ultimate flexibility to figure out exactly what your system needs to do. Then, once your logic is totally proven and locked in, you transition to the right, production with the PLC. This gives your finalized design the rock-solid reliability, certification, and durability it needs to survive the harsh factory floor for the next 20 years. But that leaves us with one incredibly exciting question. What if you actually want these two totally different devices to talk directly to each other? What if you want your cheap, scrappy Arduino sensors to feed data directly into your heavy-duty PLC? Are you ready to connect them? Think about the protocol known as RS-485. How is industrial communication actually set up between entirely different tiers of hardware? Well, that is a massive, fascinating topic, and it's exactly what you should be looking to explore next. Thanks so much for joining me on this explainer, and keep innovating.